Hey everyone, welcome back, and thank you for joining us again in our next discussion of statistics. Jumping into our first objective then, we want to obtain a stratified sample, which means we need to discuss what a stratified sample is. So first, the idea with these stratified samples is that we're going to separate our population into non-overlapping groups. We call these groups strata. You see in the diagram there, what we're saying is we're going to separate our population. In this diagram, we're separating our population by gender. Once we have the population separated, we obtain an SRS, as previously discussed, but from each group. That would be your stratified sample. Taking a look at an example then, we're told in 2008 the U.S. Senate had 47 Republicans, 51 Democrats, and 2 Independents. The president wants to have a luncheon, but instead of just grabbing 9 people, he wants specifically 4 Republicans, 4 Democrats, and 1 from any party. So we can't do a simple random sample. Instead, we need to use a stratified sample in order to make sure these requirements are met. To obtain a stratified sample, we first separate the Senate members according to their party affiliation. So we're creating groups here, like our strata. Then we conduct a simple random sample of each group rather than a simple random sample of the population. And that would be our stratified sample. That takes us to our next objective, which would be systematic sampling. Now, a systematic sample is a sample obtained by selecting every kth individual from the population. Note that the first individual selected is a random number between 1 and k, and this gets a bit technical. So here are the steps in our systematic sampling when we know the population size. First, we want to determine what is the population size, which we know is capital N. Then we want to figure out what is the sample size desired, which we know sample size would be lowercase n. Typically, this will be given to us by the problem. Next, we want to compute n, the population size, divided by the sample size, lowercase n. But we have to remember always to round down to the nearest integer. That way we don't overshoot our population size. This will be the value that is k. From there, we create the starting point, which we're going to call p, by randomly selecting a number between 1 and k. That means our sample will consist of the following individuals. P, which would be the first individual selected between 1 and k. Then we take that value that is p and we add k to it to create a p plus k. That would be your second individual. After that, we're saying algebraically we would go p plus 2k, meaning we've already added the kth, the interval that we're adding. We're going to do that again, meaning p plus k would be p plus 2k, again mathematically speaking. Not a huge emphasis, but we can use this when they ask us to find specific values. We get the entire sample by following this pattern, p plus 3k, plus 4k, etc. And then the last individual selected would be p plus n minus 1 times k. Now it's n minus 1 because we started off with p plus what would be a 0k over here. So the pattern would be our first, second, third, fourth, etc. individual that are selected. But a lot of times in a classroom setting, what you'll be asked would be to find the first individual selected and the nth individual selected. So it would be beneficial to remember this algebraic approach so you could jump straight to that last individual. And that would be our systematic sampling. Let's go ahead and do an example of obtaining a systematic sample then. We're told a quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine to verify the machine is working properly. The machine fills 500 bottles every hour. Obtain a systematic sample of 25 bottles. So as previously discussed, we need to first determine the population size. But in this case, there are a bunch of bottles. This machine just keeps on going and going. So instead of us being given a population size, which would be more typical, we're going to say let's call the population size 500, since that would be us looking at bottles for about an hour. Next would be to determine the sample size desired, and they told us that we had our lowercase n, that would be our 25. And that means we want to compute the population size 500 divided by our sample size 25, being sure to round down to the nearest integer if necessary. Well, 500 divided by 25 would be equal to 20, and make sure we realize that would be our value of k. Next, let's create our starting point p by randomly selecting a number between 1 and k. This all depends on how technical we want to get, meaning a random number generator or some sort of software approach. Instead, we're not worried about it too much, so I'm going to throw out a nice happy number like 15. Now we're ready to go ahead and gather our sample then. We know the first individual would be bottle number 15, since that's our value of p. And then remember to get the next bottle that we're selecting would be p plus k. 15 plus 20, our value of k would give us a 35. And you've got your second bottle that we'd be selecting. To support it a little more visually, remember our pattern is just p, then p plus k for the second individual, then p plus 2k, p plus 3k, etc. So we're able to follow that pattern to get each of our individuals that we're looking for. After bottle 35 would be bottle 55. After 55 would be 75. And we just keep adding 20 to find the next bottle in line. The part we do want to draw attention to would be this last bottle. Instead of listing out all 25 bottles, a lot of times they'll ask us again to list the first few and then the last bottle to be selected. We know P would be 15, so we can substitute that value. N minus 1 would be our sample size, 25 minus 1, and then we found K to be 20. Using our calculators, we end up with a value of 495. Therefore, the last bottle that we're selecting would be bottle number 495. And we've got our sample. Moving over to our next objective then, we're going to discuss a cluster sample. A cluster sample is one that's obtained by selecting all the individuals within a randomly selected group. And the emphasis here is that we're selecting all individuals within a group, as this tends to be confused with stratified sampling every so often, but we'll elaborate on that in a bit. An example that you see here in our diagram then would be we've got this school administrator. The administrator wants to obtain a sample of students in order to conduct a survey. She randomly selects 10 classes out of all of the classes, but within those 10 selected classes that were randomly selected, all the students get surveyed. So we're randomly selecting a group rather than randomly selecting individuals. And then when we have those groups, we're surveying everyone within those randomly selected groups. And the last little quick idea then would be multi-stage sampling. Multi-stage sampling simply uses a combination of the various sampling techniques. Most large-scale surveys use multi-stage sampling. The idea here in the classroom setting though is if you recognize there's more than just a simple random sample or stratified sampling going on, where we have this combination of stratified and then maybe cluster sampling within it, that's how we know it's multi-stage sampling. Now before we head into an example, let's just do a quick comparison to elaborate a little bit on the difference between these different sampling methods. First, the idea of simple random sampling. That's our fundamental level, of course, where we have the entire population and we're saying that we are just selecting at random individuals from the entire population. Then we went into the stratified sampling. Remember, stratified sampling means that we have our population and we're saying let's select groups within the population based on some criteria. After we have our groups selected though, we randomly select individuals within those groups. That's the biggest difference between stratified and now jumping over to cluster sampling. With cluster sampling, we have the entire population. We split people into groups just like we did with stratified sampling. However, instead of randomly selecting people within each group, we are randomly selecting the entire group. So we do not randomly select individuals within groups. Instead, we take an entire group that is a cluster of individuals, hence the idea of cluster sampling versus your stratified sampling. And of course, systematic sampling, a little bit easier to recognize. That's where we're taking every kth person. In our example here, we have every third person being selected, so K would be 3. So let's wrap up the topic then with our examples here. First, we have an internet service provider randomly selecting 15 residential blocks from a large city. It then surveys every household in these 15 blocks, and that's a big deal to us since we're surveying every household as they try to determine the number that would use high-speed internet service if it were made available. So first they are randomly selecting 15 blocks from a larger population that would be the city, and then we're surveying every household, not randomly selecting households within these 15 blocks. Since we're surveying every household in those 15 blocks, that makes this a cluster sample. Moving over to example 2 then. Officers for the DMV pull aside every 40th tractor trailer passing through a weigh station, starting with the 12th, for an emissions test. Since they're pulling aside every 40th, this is a little more straightforward of an example, as we've got systematic sampling. And finally, Cypress College wanted to get a sense of how their college population would feel about a raise in tuition. To do so, they took a simple random sample of 15 faculty members, an SRS of 15 students, and another SRS of 15 administrators. So they have split the college population into different groups, and these groups are strata this time because we're randomly selecting 15 individuals from within those groups. They're not taking the entire group, that would be all of the faculty or all of the students or all of the administrators. Instead, since we're randomly selecting people within each group, that means we're working with a stratified sampling technique. And we're all set with our different sampling techniques. Thank you again for joining us for this discussion of sampling techniques.